Hello everyone, I'm Dae-Hyun Ko from the Department of Laboratory Medicine at Asan Medical Center. Today I would like to talk about the laboratory support of ABO antibody monitoring for ABO-incompatible transplantation. Part of this presentation was supported by the research grant of the Korean Society for Transplantation. This figure illustrates the reason why ABO-incompatible transplantation had been considered impossible. The ABO antibody activates the complement system, followed by various pathological processes that lead to endocellular damage, inflammation, thrombosis, and ultimately graft dysfunction. Therefore, the complement activation is the most important step in this process. Thankfully, the hurdle in ABO-incompatible transplantation was overcome due to the development of various desensitization techniques. The details of the protocol are different in each institution. You can see the basic scheme of the process. The baseline ABO antibody level was first determined and then reduced by various techniques including rituximab and apheresis techniques. When the antibody level drops down below a certain threshold, transplantation is performed. In case of antibody rebound after transplantation, additional antibody depletion and immunosuppression is applied. You can notice that the medical decisions are largely dependent on antibody level. Then, how can you measure the antibody levels? Various measurement methods have been developed for ABO antibodies, and the antibody titration method shown here is commonly used. In this figure, the titer is read as 16, which is the last dilution step with positive hemagglutination. However, the antibody titration test has several limitations. The test is not yet standardized, and there are significant degrees of inter-observer and inter-laboratory variation. And antibody titration is by nature semi-quantitative. Last, it does not reflect the in vivo activity of ABO antibodies. Therefore, we tried to develop an alternative approach to reflect the in vivo activity of ABO antibodies. As I mentioned earlier, the complement activation step is the key step in ABO antibody. So, this is the basic scheme of the newly developed test. The test sample of interest is incubated with A or B cells. After appropriate incubation time, human complement solution is added, followed by secondary incubation. If the complement system is activated, the target red cell would be destroyed, that is, hemolysis. We can easily measure the free hemoglobin level in the supernatants using a spectrophotometer. We found that this complement-mediated lysis activity is well correlated with the titer levels. But within the same titer, there are wide variations in hemolysis activity. That is, the titer levels are not enough to reflect the in vivo activity of ABO antibodies. In summary, ABO antibody testing is crucial for successful ABO-incompatible organ transplantation. But there are many unsolved issues, and we need to further advance our test methods to overcome these issues. Thank you for your attention.